to another episode of Undercooled, a materials education podcast. We are here today with yet another special guest. You will not have to listen to me and Steve talk forever. Instead, we get to hear from Ellen Solomon, who has graciously agreed to participate in today's episode. So, Ellen, welcome.
Thank you.
And we always want to start off just by learning about our guests. So if you could tell us who you are, where you come from, how did you end up here, and what are you doing now?
Yeah. Well, I'll first start off by saying thanks for having me here. And so I actually currently work at the University of Michigan. I am a program manager in the College of Engineering for the Multidisciplinary Design Program, which I'll just say is a program that provides experiential learning opportunities for students. So my education and training is actually in materials engineering. My journey started back in 2008 when I started school at Iowa State University. I did materials engineering, and I specialized in ceramics and metallic materials. I decided I was really interested in learning things on a more deeper level, which brought me to research. So after graduating in 2012, I came to the University of Michigan, where I got my PhD in material science and engineering. I worked under Professor Emmanuel Marquis, and I studied the precipitation behavior of magnesium rare earth alloys. So I did that for 5 years. I graduated in 2017 with my PhD, and after that, I spent a handful of years at a engineering and scientific investigation firm here in Ann Arbor, where I did failure analysis investigations and provided expert witness testimony in cases. Worked on all sorts of different projects in that experience, which exposed me to diverse teams, diverse projects. I really got to sort of, spread my wings in my sort of engineering toolkit. So that was really fun. But after a while, I decided I wanted to make a career change. So I actually participated in the Career Design Fellowship, part of the Alumni Association here at the University of Michigan, and kind of came to the decision that I wanted to be a program manager. And kind of like fate, the position with MDP became open, and it was perfect because it had to do with faculty research. And being that I came from a research background, got my PhD, it was pretty perfect. So that's what brought me back to the university. And of course, I love working with students. While I was at my prior employer, I was part of the committee that sort of ran the internship program there. And so I enjoyed mentoring students and kind of seeing them learn and grow. And so, I was very excited to work with more students.
That's awesome. And of course, we invited you here because you're part of this multidisciplinary design that you mentioned that I think is a really unique program and very unique to Michigan. I know that I've been involved in the industrial side of it. I'm doing my fourth one right now, and we're just choosing our students. And every year that process evolves, and I am so confused by it, but I'll be reaching out to Jen. At any rate, I thought it would be a good time for you to explain what is MDP, and we're eventually going to get to the point of what is the role of materials in MDP. We'll end with that, but this is a materials education podcast. So I think Tim and I were thinking it would be really interesting for the materials community to hear about what we do with MDP at Michigan in both the research side, the sponsored side, and in my opinion, of course, materials plays a very outsized role in this. And so let's start with what is MDP?
Yeah, so MDP, or the Multidisciplinary Design Program, is a program in the College of Engineering that started in 2008 to provide more experiential learning opportunities for students to basically take their classroom learning and apply it to real-world engineering design problems. And so actually we started as a multidisciplinary design minor, but students didn't always have the time for the extra 15 credits that they would have to put into their schedules. But students want project experience. And so MDP started providing project experiences, and to this day, we offer 3 different types of projects that students can get involved in to gain experiential learning. There's the industry-sponsored projects, which is very much like a capstone type project where students get to work on a real design problem that lasts a year, and they get to work with an industry partner. We also have the faculty research side of our projects, and that is another avenue for students to gain research experience. It's very similar to Europe, except these are multi-year experiences, and students can grow into leadership positions. We also have the student organization side, which is sort of like an independent study or sort of chart your own path kind of choice, where students can get credit for the project that they're working on, say in a student organization, and get the mentorship from the faculty advisor for that project. So a little bit about the logistics of the program. So we do a lot of our recruitment for the faculty research and partner-sponsored projects, which is what I would say is like the core of MDP, because that's where we provide most of our support as staff. We start projects in the winter, so we're recruiting in the fall, start in the winter, and the projects end in the fall, except for the faculty research and student organization projects, which are ongoing. But students basically participate for a year in all the projects.
There's so much there. I'm wondering, and I'm even thinking back to the student experience of once upon a time, I wish I, that kind of thing.
Yeah.
I'm wondering what you see in your background that helps you with this sort of role of doing the program management, but still needing to interface with students and help them make connections. And how does your experience as someone who has gone through the whole academic life cycle, but also in engineering specifically, how does that influence what you do in your role in MDP?
Yeah. So I would say my role, my experiences have really prepared me for this type of role, because basically, the type of support I provide is, what you have to think about is that many of these students, this is their first time working in an environment that is not a classroom environment. They're having to collaborate with other people, apply their education to open-ended problems, which can be very complicated. And then, add the social aspects and the teamwork and learning how to collaborate can be really challenging. And, in particular for research students, that's a whole nother environment. They have to get in the lab. Research is kind of, it is open-ended, but it can sometimes be like, where are we going with this? What's the big picture? And so my role is to really help support the students by transitioning them to research so that they can be successful. And then ultimately, so that the faculty can be successful, so that they can publish research. These are undergraduates, and again, this is their first experience. And so having somebody there who has sort of been through it, not only as an undergraduate who's done research, I was part of a research lab, I also did an internship, so I have industry experience, and then also I did my PhD and have seen a successful PhD over the course of 5 years. And so I know how to plan a long-term research project. And so, and I've also been a part of teams, very diverse teams as part of my consulting experience. And so I think I bring a lot of insight from my experiences to help students, and I do so through one-on-one coaching, leadership and professional development skills workshops and trainings for the students in the first program. And also I plan and implement a summer program for students who are staying over the summer to provide some enrichment opportunities. So I initiated a mentorship program where I connect students with alumni of the program so they can, really see how they can leverage their MBP experience for professional opportunities. And then, I also plan a grad school workshop series where I give sort of my advice or just my insight as to like what are important things to consider if you're thinking about grad school. Because a lot of these students are thinking, oh, I want to get a PhD, and they're freshmen. Do you want to get a PhD? Let's think about this. What are things you need to be thinking about, and what can you do now to prepare for it? And so we talk about PhD, the difference between a master's and all that. And students have really appreciated that that level of support for things that are not just what they're doing on their projects. And so, so that's kind of where I provide most of the support to the students in particular. As you can tell, it doesn't really have much to do with my technical background, like, oh, how much materials knowledge do I have? But as an engineer, quite a bit of support there because they can relate to somebody who's already been through the whole process of, being an undergraduate through a PhD. But I will say, I do try to learn from the students as well, because while I do share a lot of experience, there are things that students nowadays experience things that I did not. I did not go through COVID when I was a college student. So I'm having to sort of adjust and really figure out what do students need and meet them there.
Right. One background question I'm wondering about, as you mentioned, freshmen coming in either believing that they know what they're going to do and maybe being wrong, or coming in and having no idea what they want to do. Did you know that you wanted to go into material science before you even came to college, or was that something you discovered as a student? Like, how did you end up in the field?
Yeah. So I became aware of materials engineering through my chemistry class in high school. My teacher, Mr. Z, he was pretty awesome, and he actually showed a video. Like, we were just talking about videos before recording this and how inspirational they can be. And in this case, actually, it didn't take much. It was a very old and super outdated video. I don't even think they used the words materials engineering. If I remember, I had to actually go hunt for it. Like,
was it on a
what is this
VHS
thing?
tape
Yes.
on the TV on the rolling cart?
Yes,
Yeah.
it was a VHS tape. And I remember like getting butterflies when I watched it, and I'm like, this is so cool. They were talking about making materials stronger yet lighter for like race cars. They were talking about biomaterials where you can have bioregenerable bones, so you can like implant the implant into somebody's body and have it absorb while also like healing the injury. And I was like, this is fabulous. This is, I mean, I just got so excited about it. And I was like, hey, Mr. Z, can I like borrow this video? I gotta watch it again because I can't remember. Like, I just want to know more about what they were talking about. I just wanted to keep watching it. And so I watched it again. I'm like, I don't know what this is. And I was just talking to some friends, and somebody had a cousin who was doing materials engineering. And he's like, you know what? I think my cousin did that. I think it's called materials engineering. And I'm like, okay, I gotta look it up. So I Googled it, and I was like, yeah, that's it. That's what I like. That's cool. So anyway, so that's what got me interested. And I declared right away, and just kind of went along. I'm trying to think when I decided to get a PhD. I think I was interested my sophomore year, which is very early, but I don't think I really decided until my junior year after doing an internship, because I went and did my internship, and I was like, I just had this desire. I'm like, I feel like I'm working on my intern problem, and I'm like, I just really want to understand this deeper. I like the why. I'm always asking why, and I want to explore that more. So, and actually, it's funny because all of the research I sort of selected was kind of related to this video I watched. I actually, my undergrad research was in a biomaterials research lab doing the implants that they implant and have absorb in the body while they're healing the fracture. And then when I came here, I was studying lighter yet strong material for light vehicle lightweighting.
Right.
And so that was pretty cool to do that, like kind of full circle.
What an awesome story.
So
I
good.
love hearing stories like that.
Yeah.
Where did you do your undergraduate?
It was Iowa State University.
Oh, great
Yep.
place.
Yep. So, I'm from Northwest Iowa. I grew up on a farm. I'm first gen student, or undergrad, like a college student, and then also a PhD. So yeah, and that's where
But you
I all
said
began.
something interesting. You said while you were in undergrad, you got to do research. And so you got to get an idea of what it would be like to go to graduate school. And it makes me so sad that many students don't understand that they should try research. So they, even if they decide they hate it, they just learn something really valuable for them.
Totally.
And listening to you talk about what you do for this program, I'm like going, wow, that's what I do as an undergraduate program advisor. And of course, in our department, half of our students go to graduate school. The other half go right into industry. But I try to get them all, the day they declare, I want to talk to them about what they might want to do. And I suggest, why don't you try just one credit of research, just to see what it's like.
Yeah.
You might walk in there after a term of just going to group meetings and doing a little literature review. And you might say, wow, I don't think I want to be like those graduate students. They're being abused by their advisor. They're having to work really, really hard. They're not getting paid that much money. I'm not doing that at all. And that's a really valuable thing for them to learn. Or they might have the other conclusion, wow, these guys are getting paid to go to school. And look at all the cool stuff they get to do. And wow, the advisor's actually helping them learn how to handle adversity when they get out in the real world, where they can deal with it in this nice safe space. So it prepares them for when they're not in a safe space. And I want part of that. And it's a totally different thing. So it's so important to let students have these experiences. The whole idea of experiential learning is so valuable to help students craft what they're going to do in the rest of their time they're in undergraduate. So they're in the perfect position when they finally leave to maybe say, gee, I can be a PhD, I can go get a master's, I can go get a job, I can go to law school. And I got into all of those things. Now what do I do? What a wonderful dilemma to have when you graduate, so you can choose between all of those after having these experiences.
Yeah. And that's what I tell students. Get the experiences you want to try out. And college is a time to try things. It doesn't, and I'm not saying do everything under the sun, because there's not enough time. You need to find maybe like a few of the things that you're really passionate about or just want to try, and then try it for a while. Because like with research, it takes longer than a semester to really get into it. And so, that's why MDP is a 2-semester requirement, because you spend the first semester just figuring out what to do in the lab. What is your position? And then what am I doing? And so having that second semester to really okay, now that I've sort of laid that foundation, now let's be more productive and actually do something and really see what it's like to do research. It just takes time. I remember as an undergrad, it took me a long time to get acclimated, and being first gen, I just feel like it took things a while to really understand what things were like. Research was totally different. I had no clue what it would be like.
Yep.
So it is good to sort of take some time. And
Could you give us a couple examples of what some of these academic research projects look like in the MDP setting?
Yeah, sure. Like what kind of topics they are and stuff. Yeah, one that I find to be really cool is called MUROM. It stands for Multi-Legged Robotic Robots and Animal Motion. So I probably messed that up. We use a lot of acronyms, just like Michigan does. And so basically they're designing really interesting robots out using novel materials in novel ways, and they're designed after animals, in particular insects. And so the whole idea is that typically robots are designed to be very specific and without, it's to be very precise, basically, robots, and they can be very difficult in certain environments, whereas this lab is using robots that aren't so, specific. And so it's a way for them to figure out how robots can be more, versatile in different environments. And then another project we have is actually in the medical field. And so we work with the School of Nursing on a project that is basically creating tools to handle big data sets in the health sector. And so it uses a lot of like computer science and data science and things like that. So very diverse projects from robotics to healthcare to education. I mean, we really cover quite a bit of research areas.
Any materials projects?
So our projects are definitely multidisciplinary in nature, and so they're materials embedded in these projects. So no, we don't have we have one project with a faculty member who has, split appointments across many departments, including materials science. But the project is sort of robotics focused, but definitely includes materials challenges where, there's material selection, there's having to understand how materials behave in the design so that they can understand their robot designs. And so, that's what's unique about MVP is that you can, as a materials engineering student, you can sort of, marry your materials engineering interest in education, but also combine it with maybe another interest you have. Maybe you're curious about robotics and you want to work on a materials challenge within robotics. And so that's fun, something different.
So I know that in the industrial side, our department for our students will let them use 3 credits of the 7 credit experience towards their science and technical electives. What about on the research side? Do they get credit for that?
They do get credit, so all of the students who participate in our program can enroll for credit. It just depends on the department as far as if they can take that credit and substitute it for something else. And so on the research side, there's some projects that get certain robotics or mechanical engineering high-level research credit. But for the departments that maybe we don't have an already embedded agreement with the department, the students can petition to their own department to say, hey, this is what I'm working on in this research. Can I get XYZ credit through this program? And they can, sort of
I'm trying to understand how it's
themselves.
different than, so in our department, we have a course called MS&E 490, which is undergraduate research. That has to be run by one of our faculty or one of our courtesy faculty, but it has strict rails. So you can use up to 6 credits towards your degree, and 3 of those credits can be used to substitute for an MSc elective course. And we leave it pretty much up to the research advisor to figure out whether the student did enough work. But we do require the student write a research proposal for more than 1 credit. And so I'm not sure how the MDP version of this goes. Everything they do for these credits is research. Whereas is the research side like the industry side where they have to have meetings and keep an agenda? And so there's a lot of other things that I know MDP asks students to do to give them the experience of what it would be like to work in a company, a lot of which is not really technical, but administrative, business sense, teamwork, all of those things. Are those components in the research side?
Right. So there is a big difference in kind of how the different projects are administered. So the industry project, yes, they follow a highly structured curriculum, if you will, where, they have set assignments, design reviews, expectations for the agendas and everything like that.
Gantt charts.
Yeah, where they're being graded on this stuff. And so, and often graded by MDP and stuff. So For the research side, MDP has less structure that we apply to the program. So no, they're not handing in assignments to me or MDP. It's all kind of on a team by team basis as far as like requirements, like assignments. So it is very much run like a research lab where the students are expected to come in with a research update every week that the faculty says what they want for their update. So maybe it's a PowerPoint presentation, maybe it's a Word document, however it is, like the format of their updates. That's sort of specific to the team. But yes, they have an agenda for these meetings, and usually the students are expected to contribute to that agenda. But again, they don't hand it in to MDP. We don't grade them. So it is less, I guess, on MDP to grade, and it's all on the faculty to sort of set their policies in their research lab and what works for them. Although I do provide a lot of guidance and support on best practices and what works and what I want them to do in terms of like, hey, we should be grading on these aspects, and here are ways that you can sort of evaluate or assess these things. So, participation, like, are they showing up, and what are the updates? Okay, let's grade them on a weekly basis, just like industry sponsor does. But there's a little more, I guess, leeway for the faculty on what they do specifically.
Are you familiar enough with the industrial side to give us an example of some industrial projects?
Well, I can give you an example of a historical one that we did. Now, it was before my time, but actually it was the one that you mentored, and that was the Kellogg's Pop-Tarts one that people tend to really like, and it is pretty interesting. So the project was to, have a mobile app controlled modified 3D printer to create personalized Pop-Tarts for Kellogg's. And so this was like a truly multidisciplinary project where, you had the CS side for, creating this mobile app to then control the modified 3D printer, but then there was the mechanical side to actually design this modified 3D printer. And then there was the materials side where they had to come up with a frosty material that would be extrudable in the modified 3D printer, but then print a 3D design in the custom design that they wanted on the Pop-Tart. And so that was a really cool challenge. And again, truly multidisciplinary. And students had to really kind of work across boundaries there and not just consider the materials aspect, but really work with, say, the mechanical team to be like, well, what are your design requirements, and figuring out together what works for all sides to make this work.
We even had a master's student from the School of Information who is expert at observing children and whether or not they like stuff. So we did a demo. We brought it to the Hands-On Museum and had kids coming all day. And this guy took all these notes, and then we changed the product to make it more appealing to little kids. And then when we had the design fair in the Duderstadt Center, there were so many people around our booth, especially because they bring in like high schools and stuff, and it was great.
That's cool.
But again, that was material science, because you can't 3D print icing because it goes bloop.
Yeah.
And you had to adjust the TG to get the right glass transition temperature higher so it stayed rigid enough for the next pass to come on. And our only design requirement was that it didn't have to taste good. And it wasn't allowed to kill people. So there's been a lot of hype about 3D printing of food, but it never made it to market because they used powders. And so it was always toxic because the powders had too much surface area and you get too much absorption of nasty bacteria and stuff. And so, but icing's different because icing's not a powder. So it actually worked. It was kind of cool.
Yeah. No, that's super cool.
That's fun. You've talked a little bit about sort of the student experience in terms of what they might be doing on a week to week, or some details about types of projects that they're in. When students are going through these projects, which you've said take a year, do they have a finish line in mind when they start? Is there an expectation for what they're supposed to produce at the end of this all and what deliverables might look like? How do they know what they're getting into?
Yeah. So, I mean, because these projects are so open-ended and nobody really has a solution for it, we can say, like, this is kind of what we maybe think they're going to be working on, but we don't know what the end result is going to be. Will it work? We don't know. Especially with these industry-sponsored projects, sometimes it's like, what they find out is, sorry, this design won't work. This is what we tried. What we are looking for, though, is that they're doing the steps to figure it out. Like, they're following a logical path. They're following the design process. But if in the end the thing doesn't work, that's okay. It's less about kind of what the end product is and more about, like, there was good thought behind it and good processes in place to get to the end. So yeah, and then as far as deliverables, it kind of depends on the client or the sponsor as far as, like, will there be a report, or maybe at some point they will kind of see what the product will be, but yeah, we don't always know exactly what it's going to be at the end.
Yep. And with the students who are going through this experience of not having a known destination, not having a sort of, there's no test at the end of it that they can say, oh, I passed the test, I'm a good student.
Yeah.
And they're so trained in their school careers to learn the facts, do it right, get a good grade, get a pat on the back, move on, do it again. How do you see students just dealing with this experience of suddenly being in a place where the rules of the game are totally different to everything they've previously thought of as school?
Yeah, it's tough. There's definitely a recalibration period of, hey, you got to, like, reset your expectations. This is not a cram the last minute all night and you're going to be able to solve the project. This is a long-term marathon project where, to them, marathon, right? Like,
Yeah.
it's just a year. But, this is something you work on, and this is both research and industry. This is something you just consistently work on for a year until in the end you have the thing that you produced. And so it takes a lot of hard work. It takes collaborating with your team. But yeah, it is open-ended, and yeah, it can be hard for students to work in that environment, but that is what they'll expect when they get out of school, because that's how the projects are. It's very open-ended, right? There may be a deadline, but nobody telling you how to get there.
Yeah. If you ever figure out the secret recipe for getting students to chunk out their work appropriately
Yeah.
and not try to sprint the marathon 24 hours before, please tell me your secret, because even with month-long projects, I'll still have students try to do it in the last 2 days, and it's just,
Yeah.
you did this to yourself.
I know. It's hard to set that behavior and expectation, and hopefully with the assignments that we have, at least with the structured projects, like industry sponsored, hopefully that's getting them to, like, force them to do it, right? Like, inching them along. But yeah, I think it's not until that second semester do students kind of get it and, get a little better at it.
Right. And that's kind of also the role of the faculty mentor, is to keep them on track, because you meet with them every single week. So that's good. You get to touch them every single week, and they meet separately more times than that. And so we have, short-term goals and long-term goals, and it's the faculty mentor's responsibility to manage that, and with a lot of flexibility. But I'm always disappointed that it's only a year-long experience. And you said something interesting. You said some of these research projects go multi-year. So what fraction actually, because you're absolutely right. Research is a marathon. You don't do much in one term. You really should spread it out over 2 years or 3 years to get something done. And anyone who's done a PhD knows all about that. So how many students actually do it for more than a year?
Yeah, so our target is like 6 students per project would be great, to get that level of return. Just because that's kind of when we start to see, a steady culture to stay on the team, kind of keep the momentum of the team going. And really it just kind of varies by the year, but I would say that's like a really good target. And so yeah,
6 out of how many?
we have about 150 students usually
Right.
per year, and I'm talking like per team, and we have 9 teams. So yeah, so it's a it's not obviously a ton of students, but we just need like a good amount of students per team to kind of keep things going.
Can you talk about the impact on the students? Like, I imagine that with research, a lot of students end up going and getting their PhDs, and I imagine that this MDP project helps them get into better graduate schools. Do you have any data on that?
On who goes to grad school,
Yeah.
it's not something we can easily track, at least not at this time.
Okay.
It's not something we track super closely. I mean, we serve students all the way from freshmen through masters, and so it's quite the spread, and students are making a lot of changes throughout that time, and so it would be a matter of having to like really track them through that process, and then after they graduate, and some maybe they're with us for the year and then they're gone, and so it's unclear where they go afterwards. I can say just anecdotally without like real data, it's like to see I've spoken with students who they go to grad school, so they're definitely there, they're using MDP as a way to gain the experience, and I can say like whether you do the research or you do the industry sponsored, it sets you up either way to go to industry or go to research. You don't while I agree that getting research experience is good just so you can test it out, because a 5-year PhD or longer, it's a long time, and you should really know if you want to do it before you go, because it is such an investment. But you don't have to do research every year of your undergrad to set you up for that. You can do these other experiences that give you valuable skills, like problem solving, learning how to work with others, planning your time, planning your project. You can get that elsewhere as through other avenues as well.
Do you hear stories from students who have completed the program who say, for example, oh, I went to this job interview and then I told them about my MDP project and they thought that was super cool that I had some sort of relevant engineering experience? And I'm thinking of this partly as an opportunity equalizer where some students don't have the social capital to get internships in industry or to know how to land a summer research position. And so for them to have this way to get an experience that's equally valuable from a resume point of view, do you hear from students afterward that this helped them in that way?
Oh, for sure. I mean, we get students a lot of times telling us that their MDP experience set them up for either an internship or a future job. Some students will actually go on to work for the sponsor that they, did their project with. So that's really a huge opportunity for the students. Some of our sponsors offer, guaranteed internships, and so we get a lot of students, applying for those projects. But then many projects just offer, guaranteed interviews. So even just to have the experience of talking in an interview to, a potential employer is very educational for them as well. I would say a lot of students seek out MDP for that professional sort of building of their resume to prepare them for future opportunities. And even if they don't get an internship, honestly, MDP standalone is pretty good for, having that experience on their resume.
Yeah, I know in the 3 MDP projects that I've mentored, I'm doing a 4th right now, so I don't know how that's going to work out. But the other 3, the students got to go to those industries and work in the industries, or at least present to people at the industries. And that was amazing. My last one was Northrop Grumman. The project was to mine helium-3 from the moon. Pretty crazy project. And they flew, the entire team down to Northrop Grumman's headquarters in Herndon, Virginia. And the students gave a presentation, and the chief engineer for all of Northrop Grumman showed up and asked really hard questions. It was unbelievable.
great.
He gave us a whole tour of their satellite manufacturing system. And you could see it in the students' eyes. They were just blown away by that experience, that as an undergrad, they got to see all of this and get the inside track.
Yeah.
That alone was just incredible.
Yeah, I mean, while working on these problems, they're learning what it's like to be an engineer at these companies, right? They're learning what it's going to be like after, they graduate from school. And even for the research side, we have many students who publish papers, get involved with patents, even maybe start a startup. And so they've done some pretty incredible things even within the research side. I mean, even just presenting at a conference is a huge experience for a student to be able to, well, one, they did so much in their project that now they can go and talk about it. And just the experience of talking about research and all that definitely gives them sort of insight into what it would be like to be a grad student and maybe future faculty member.
That's wonderful. There's so many avenues of student success in this program that you've just laid out. I do have to wonder, institutionally, like on the university side, what does success look like for the MDP program? What is it that you sort of go upstairs to the administration and say, MDP is awesome, we should continue existing for all of these reasons? What are your metrics for success for yourself for the program?
Yeah, so I would say our main goal as a program is to just provide as many experiential learning opportunities to as many students as possible and have them be accessible and high quality. So that's really our big goal. So we want to be able to serve as many students as possible, meaning we need to make sure our portfolio of projects is meeting the needs of students, right? I mean, as CS grows, we need more CS projects and all of these things. And so that's a really important thing to us. And part of making it high quality is our relationships with our faculty mentors and having good faculty mentors mentoring the students, right? You meet with them every week, and it's to talk with them and help guide them in what they're doing, because students without these experiences don't get that high quality mentorship relationship with a faculty member that is helpful for future recommendations for graduate school or references for say a job. Those are important things, not just for those documents, but also that's helping their learning through their interactions with the faculty and the sponsor. And so I kind of forgot where else I was going with this.
So what I'm hearing is MDP is awesome. Everyone should have one. Everyone should do it because everybody wins. I feel like that's kind of the takeaway here, right?
So it is good. I would say, like, specifically for like materials engineering, I mean, it's really beneficial to be doing opportunities like this because it gets you out of just materials engineering, right? You can apply your materials engineering knowledge to other problems. And what I like about it is I like the real world aspect of it. Coming from industry and working in teams, I feel like more students need that experience of, well, what is it like to work with a team with mechanical engineers, computer scientists? So, not only are students challenged to think, well, how do I pick a material for this design? They're having to be like, well, what are the mechanical considerations? And now I got to collaborate with my mechanical folks to really figure out this design and work together to make it work. And so that's really exciting. And other things that we're really excited about the program is, I said make it highly accessible, right? And part of that is offering good degree credit for students. And so we're really proud to have 26 agreements across 18 different departments to offer degree credit for students. And so that's really important because it makes it possible for all students to participate, because not all students have the time and the money to do it. And so really incentivizing them and giving them, more for their experience is a really good point of pride for us.
Yeah. I love what you said about this being an opportunity for materials engineering students to actually work with other kinds of engineers. I know when prospective students are coming in and they ask, okay, what's materials science? And one way I describe it is we're sort of the central node of the engineering disciplines network, because
Yeah.
everyone has to talk to us at some point. Mechanical engineers, what do I make it out of? Aerospace engineers, what do I make it out of? I mean, there's more to life than materials selection, but that certainly is something that I think all engineering disciplines kind of understand is important. And students say, wow, that's awesome. I want to be the bridge that connects all the other engineers. And then they come here and they take thermo and kinetics and the structures, and they never see anyone who's not
Yeah.
an MSc student. And suddenly they're ready to graduate. And I say, okay, now you're going to go work with, but in the middle, that breadth, I think, can get lost. And so opportunities like this to work on real problems that require other kinds of engineering to solve is something I wish all of our students would get the chance to do.
Yeah, I agree. I wish I had that experience when I was in school, because I can say I did not. I very much stayed within the materials engineering realm and worked on a very materials heavy project with materials engineers. Yeah, so it wasn't until I went off into industry that I was like, oh, well, this is really interesting. I was always involved in projects that involved other people or just other expertise, and that was really eye-opening because they give you a perspective that maybe you didn't have before. But yeah, so it's very valuable.
So what do you think the future holds for MDP? What's the vision going forward?
Well, keep providing many experiences, high quality, and make them more accessible to students. We're always looking for ways to reach more students. We do a lot for recruitment, a lot to, reach out to different departments to get students to our program. And sometimes we wonder, are we doing enough? We're a pretty small team. We got 2 program managers, a director, 1.5 administrative assistants, and an academic advisor, and it's just us that we're reaching students across campus. We don't just serve engineering, we serve students across campus. And so, reaching as many as we can and making them high quality, and where we can, giving the credit that students deserve. We want all students, we want more agreements with more departments to offer really valuable degree credit so that more students can participate in the program.
That's awesome. So keeping a look at our time, we're probably there.
Yeah.
So is there any last things you might want to say, or
Anything you want to advertise or brag about? It's open floor.
Yeah, open floor. Well, our application just closed, so I can't promote that.
Awkward.
So we're doing our matching, but 2026 projects will be starting in winter. But for anybody who's going to be here next year, start thinking about getting involved with MDP, because it's a great experience. And talk to any friends you have that are doing MDP and figure out if it's right for you.
When would students start to make that connection? Who should they contact? What are dates that they should have in mind for timelines for getting in?
Yeah, so we start recruiting early fall, so right when students get back from summer. And so that's when you'll see us out on the diag, handing out, like up here on North Campus, handing in the Grove, handing out ice cream. We also have, definitely check out our website, because that's where most of our event information is. But that's where you're going to find information about Project Fair, which is usually like mid to end of September, and that's where you can actually meet sponsors and meet faculty of those projects, and give them some face time, show them who you are, and also learn more about the projects. And then applications usually due in early October, and then we start extending offers through the end of the semester, and then they start in the winter. But in terms of reaching out to us, you can reach out to us at any time. It can be, just go to our website and go to the contact information, and you can reach out to us individually, me or any of the other staff with any questions, and we'll direct you to whoever is in.
And we'll
should
have all
answer the
those
question.
links in the show notes
Yeah.
so that people can easily find them.
Yeah.
That's right.
Yep.
Okay. Well, I guess we're out of time. So to wrap it up, Ellen, thank you so much again for being a guest and doing this here with us today. And for everyone else out in the world, on the internet, wherever you are, thanks for joining us. And we'll see you next time on the next episode of Undercooled.
Absolutely. Thank you both.